Welcome to science class. Today we are going to learn about fossil fuels, what they are, how they form, and how they are used, and why they are the kings of energy, are questions we are going to try to answer. In the last video, we covered what energy is, and how it takes not just surprisingly large amounts of energy, but just a staggering amount of energy to do mundane things like keep the lights in our house lit. Whether it's transportation or electricity or manufacturing, or as a matter of fact, the majority of items you use every day, there are fossil fuels behind all of that. Let's get started. First and foremost, what are fossil fuels? Well, they're a type of non-renewable resource. Non-renewable resource simply means that they are consumed at a greater rate than they are replenished. But non-renewable doesn't mean we will one day run out. Metals are non-renewable resources, but there is just no way we would ever run out of iron or copper one day. Some non-renewables are in danger of running out, but do you think we will one day run out of fossil fuels? The answer is no. Now, is the amount of coal and oil in the earth unlimited? Well, of course it's not, but that doesn't mean we could ever possibly use all of it. If humans are around for 10 million more years, would that be long enough to use all of the fossil fuels? Perhaps, but that's beside the point. First of all, I don't think humans will exist for that long. And second of all, if we do manage to last that long, I just don't believe we would keep using fossil fuels. Some new technology would have to take over in that amount of time. All of the doom and gloom predictions that say things like current reserves of oil will only last 50, 100, 200 years, those are incorrect. The last time I looked, we have right now enough proven oil reserves to last more than 3,000 years. But every year we find more of these proven reserves. We are not constantly shifting from one dried up oil well to the next in a constant state of uncertainty. If we were, civilization would be utterly ruined. Instead, everything is pretty normal. When materials become more scarce, they become more expensive. But products made from fossil fuels aren't getting more expensive. A lot of them are getting cheaper. To prove the point, here's a quick statistic on oil. The United States used 7.28 billion barrels of oil in 2017. That's 8.1 billion cubic meters. At that rate, we would use enough oil to fill the Great Salt Lake in less than 2.5 years. And yet, oil is not scarce or becoming scarce. We are not running out of this stuff anytime soon. How about coal? Well, the state of Wyoming alone produced 450 million tons of coal in 2017. That is the weight of 70 Great Pyramids of Giza. But Wyoming has been producing coal for decades, and it will continue to do so. And that's just one state in one country. We're not running out of coal anytime soon either. I will shift back to defining fossil fuels. Fossil fuels are a group of molecules called hydrocarbons because they are composed of mostly hydrogen and carbon atoms, but they can have impurities. When you burn something, carbon dioxide and water are the products of that reaction. Hydrocarbons provide exactly the right ingredients when you include oxygen in the air for this reaction, so they are very good types of fuel, which is why nearly 80% of the energy used in the United States is derived from them. And we call them fossil fuels because they are the organic remains of once living organisms. The big three fossil fuels are coal, petroleum, which I'm going to just call oil, and natural gas. First up is coal. Coal forms from the remains of plant matter buried and compacted long ago from tropical swamps. Coal comes in different forms depending on how much of the original organic material has been altered. Peat is what you call the raw ingredients of coal. Peat is just any dead plant material. When peat is buried and compressed, it forms lignite, which is sometimes called brown coal or dirty coal. Lignite will burn, but it isn't very energy dense, and it produces a lot of excess pollution. Lignite can be transformed into bituminous coal over time. Bituminous coal has fewer impurities and burns longer and cleaner than lignite. The final stage in coal formation is anthracite, which is a metamorphic rock. If you compare anthracite to bituminous coal, it is much lighter and harder, but very lightweight because it's much more concentrated with hydrogen and carbon, which are two of the very lightest elements. Anthracite will burn the longest and cleaner than any other type of coal, so it's the ideal type of coal, but it's not very common. We will lump petroleum and natural gas together. Both of these fossil fuels form from the remains of marine organisms. The vast majority of oil and natural gas reserves are the remains of microscopic, single-celled organisms like algae, plankton, or diatoms. Petroleum can also be called bitumen, asphalt, or crude oil. They all mean virtually the same thing. Natural gas is really methane, which has a chemical formula of CH4, 1 carbon atom, 4 hydrogen atoms bonded to it. Natural gas evaporates from the oil itself. Methane sometimes evaporates from coal deposits as well. So we know what fossil fuels are. Now, how about how they are used? What can you do with coal and oil? What do we do with coal and oil? This is nowhere near as simple as you think, I promise. We'll begin with coal. Historically, coal was used to cook food, heat homes, and manufacture metal tools. Then the Industrial Revolution occurred, and we figured out how to use coal to make steam, and use the kinetic energy of steam to create motion. That simple innovation is still with us in the modern day. A coal-burning plant burns coal in order to make steam. That's how most electricity is made. Burn something to create steam, to spin turbines, to turn generators, to make electricity. It's kind of crude in a way, but it's done on an enormous and sophisticated level. 37% of the global electric grid is coal-powered. In the United States, it's about 39%. Renewables and alternatives are growing, but it's mostly natural gas power plants that have replaced the once dominant coal plant. But other than making electricity, coal has very few other uses. 93% of all the coal that is used in order to make electricity. The other major use for coal is in manufacturing steel and concrete. So coal can be used really in just one way. You burn it. Petroleum, though, is by far the most versatile raw material on the planet. Almost every single activity you do involves petroleum, and nearly every single product you use contains petroleum. 93% of transportation in the United States is dependent on some type of hydrocarbon fuel. This accounts for 68% of the use for oil. But petroleum products are found in everything. Here's a short list of items that are made from petroleum, or petroleum makes up the majority of the material. Fuel, paint, dye, rubber, plastic, styrofoam, insulation, acrylic, polyester, nylon, spandex, asphalt, shingles, lubricants, makeup, waxes, and ink. Just take the first 4 items: fuel, paint, rubber, plastic. It is very hard to find one thing in your entire house or garage that doesn't have one of those things in it. Natural gas is used mostly to make electricity. The natural gas power plant is great because it is not only cheaper, but cleaner. New York City used to have smog as bad as some of the worst polluted cities in the developing world today. But then they switched to natural gas, and New York City isn't known for pollution anymore. Natural gas can also be burned for manufacturing processes. Many homes are heated by burning natural gas, and it can also be used to make products like fertilizers, some fuels, plastic, ammonia, and a few other things. So to wrap things up, why fossil fuels? They get such a terrible rap, and it's technology from the Industrial Revolution. So why do we keep using them? We have batteries and wind turbines and many other things now. There are 5 big reasons. Fossil fuels are cheap, plentiful, energy dense, easy to transport, and reliable. The wind doesn't always blow, and the sun doesn't always shine. You can't make batteries that power a city and ship them around the world. But you can do that with coal. The energy from renewables and other alternatives, which will be the topic in the next video, it just isn't as easy to control, capture, store, and regulate. That is, except for radioactive isotopes. Technology also keeps improving fossil fuel efficiency. If we drove cars that were as inefficient as cars 50 years ago, that would be stupid. But we aren't. Next time, we're going to cover alternative energy resources: wind, hydroelectric, solar, geothermal, and nuclear power. Thanks for watching.